Welcome to bonding part 1. Let me share the slide with you. So for bonding theories part 1, there are 3 parts: ionic bond, covalent bond, and Lewis structure. The learning objective will be for you to be able to explain different types of bonding, calculating lattice energy, but however, we will skip this for a while. Understand and describe octet rule, draw Lewis structure, and explain if there's any exception of octet rule, calculate formal charge, and draw resonance structure. So when we are talking about ionic bond, the first thing is to understand that the bond formed between what and what. So the ionic bond usually form between metals and nonmetals. So when the metals transfer the electron to nonmetals, it becomes positive ion, and the nonmetals become negative ions. So there is an attraction between positive and negative ion, and it is called an ionic bond. So let us watch this video, which is very good in explaining the ionic bond.
We learn is changing. Universities are going online, and students, doctors, and institutions are...
Right. Professor Dave here. Let's learn about chemical bonds.
He knows a lot about the science stuff. Professor Dave explains.
A molecule is made up of atoms that are participating in chemical bonds with one another. There are different types of bonds that we will want to be able to describe, and the key to their formation has to do with the difference in electronegativity between the two atoms
Okay, the keyword is electronegativity.
Participating in the bond. If the difference is more than about 2, like with sodium and chlorine, chlorine will steal an electron from sodium. Chlorine really wants another electron. Sodium really wants to get rid of it.
So ionic bond is formed between metal and non-metal. So when there is a difference in electronegativity more than 2, then the metal will transfer the electron to non-metal and form a positive ion, and non-metal will form a negative ion.
Rid of one, so everybody wins. The result is a positively charged sodium ion and a negatively charged chloride ion. Particles of opposite charge have an electrostatic attraction, so these two ions hang out together by forming an ionic bond. This is a very strong attraction because it is happening between ions that have a formal charge.
So it is a very strong attraction between positive charge and negative charge ions. So this is what we call as ionic bond. So remember, the keywords is the difference in electronegativity more than 2 between metals and nonmetals, forming release or transfer of electron from metal to nonmetal, forming cation and an ion. So that's where the attraction happens, and it's called ionic bond.
Bond, ionic bond. Electrons taken, not shared. Speaking of shared electrons, if the difference in
Let's move back to the slide just now. So as you can see, the video explaining about ionic bonding. So we will skip this lattice energy and move on to octet rule. So one of the easiest way to understand octet rule is all about stability. So the first aim to achieve stability is to have a valence configuration similar to the noble gas core. So if you can see the sodium, this is the electron configuration at elemental stage or at basic stage. And once it releases an electron, you can see the configuration, the outermost electron configuration, or the valence electron configuration now is 8. So it is stable according to octet rule. So let's say if we remove another electron from sodium, you can see that it is 2 plus, and the outermost electron, the valence electron now is 7, which is not stable according to octet rule. So the ultimate aim is to achieve octet number of electrons for the valence electron. So most of the representative elements, okay, here and this part, usually obey this octet rule. However, the transition element, which is here, does not work well with octet rule. This is due to the first electron by an atom or ion are always from outer shell. Within the given shell, the F shell is emptied before the D, which is emptied before the P, which is emptied before the S. So due to this factor, transition metal does not work well with the octet rule.